Hassler here. I'm going to work through the 7-6B Explore. We're going to continue factoring. Remember, factoring means that we are going to take an expression and break it down into two terms or two groups that are being multiplied together. Those items that are being multiplied are called factors. Only this time we're going to work with three terms at a time instead of just working with a greatest common factor. Before we do that, I want to just review some multiplying. So number one says, right, f of x, which is equal to x plus 5 times x plus 2 in standard form by multiplying these two factors. So remember, we actually called this intercept form or factored form, okay? We're going to put this into standard form. And standard form is that ax squared plus bx plus c, okay? And so this is the box method. Remember, for the box method, we take this x term and we're going to multiply it by each of these terms along the side. So x times x is x squared, 2x. Now we're going to do the same thing with the 5. We get 5 times x is 5x, and 5 times 2 is 10. And so what we end up getting is x squared plus 7x plus 10 for my f function. We're going to do that again. We're going to do that for this new function, g, and we're going to write the terms. So we've got x and then minus 4, and along the side we have x and then plus 7. And so x times x is x squared. We've got 7x, negative 4x, and then minus 28. And so we get that g of x is x squared plus 3x minus 28. And it says in 3, what relationships do you notice between the equation of the quadratic in factored form and the equation of the same quadratic in standard form? And so I am noticing some things here. I'm noticing that the two terms here, this 2x and 5x, that's what's going to give me this middle number, 7x. So that 5x and that 2x come from the two numbers in my groups. They get multiplied by the x term, but I end up adding those two numbers with x together. Let's see if that's true down here. So the 7x and the minus 4x, that's what's going to give us the positive 3x. And again, that's coming from the two numbers in my groups. I end up adding those two numbers together once they get multiplied with an x. I noticed something else. I'm also noticing that this 10 here, which is my constant, comes from multiplying these two numbers, 5 times 2. And the same thing happens down here. This negative 28 is my constant, and that comes from multiplying the two numbers that are in my groups. And so I'm going to summarize that those relationships. There was a lot of them. I'm going to summarize those relationships down here. And I'm going to say that the x term, or the coefficient of x, I'll say, is the sum of the two constants in parentheses. Okay, and the constant in this trinomial, I'm saying trinomial, but trinomial means I have 1, 2, 3 terms, like tricycle. The constant is the product of those two numbers. And so for the most part, I'm going to say for the most part, this turns out to be the case. There are always special cases, and we'll get into those as we move. And so now that we've had that discussion, let's see if we can do this whole multiplication piece in reverse. And so up top, we've multiplied to get these, what I called a trinomial, these three terms. And so we multiplied these two groups, and when we multiplied these two groups, we got 3 terms. Down here in 4, I'm giving you the 3 terms, these trinomials. And your job is to break this apart into two groups. In other words, we're going to break this apart into two factors, okay? And so let's see what we can do. All right. I have x plus 3 and x plus something should give me x squared plus 8x plus 15. All right, well, up above we said that the constant, which is the 15, that's my constant, is the product of two numbers. So here I have 3. Well, if this were 5, then 3 times 5 would give me the 15. Okay, that seems reasonable. And the coefficient of x, here's the coefficient of x, my b term, is the sum of the two constants in the parentheses. All right, so if I multiply 3 by 5, I get 15. And if I add 3 and 5, I get 8. Oh, yeah, that seems to work out. Okay, all right. Let's see if the same thing, if we can figure this out for part B. So for part B, I've got x squared plus 5x plus 6. And I got to multiply x plus something times x plus 2. Well, let's see. 2 times 3 would give me 6. And 2 plus 3 would give me 5. Would that match? Oh, it does. Okay. So this number must be 3. And so that's really what we're working through here. I'm going to have you hit pause. And after you hit pause, I want you to try to fill in the missing blanks for C and G. And then you can hit start and see how you did. Okay, so hopefully you had a chance to give this a try. And so I filled in x plus 3 with my x plus 8 because 3 times 8 gives me the constant of 24. And 3 plus 8 gives me that, I'm thinking of the answer, 3 plus 8 gives me 11. And so I'm matching these terms. This one in G was a little bit different, and it was a little bit different because I had a plus and a minus, right? And so 4 times negative 1 gets me that constant of negative 4 right here. And 4 plus negative 1 gets me that positive 3, so it works out. Now, I think over here on this right column, things get a little bit more difficult. We're upping the game here a little bit, okay? And what I mean by that is now we have to figure out on our own what the two numbers are, okay? And so I'm trying to figure out two numbers that are going to multiply to 24, and those two numbers have to add to negative 11. And notice that I already have these signs in here for you that they're both going to be negative numbers. So that means I'm looking at like negative 1 times negative 24, but if I add those, I don't get negative 11. How about negative 2 times 12? Negative 12, right? Negative times negative will be positive. And if I add those, I get negative 14, so that's not going to work. All right, how about negative 3 times negative 8? Yeah, if I multiply those, I get positive 24, and if I add those, I get negative 11. So I got x minus 3 and x minus 8. Notice I'm not writing the negative with the 3 because I have the negative right here in my problem. Okay, so let's see if we can try another one. In this next one, I'm aiming to multiply for 6, and I'm going to pick the terms that add up to this negative 7. So again, both of my terms are going to be negative, right? Negative times negative will give me a positive 6. So I've got negative 1 times negative 6 would give me positive 6. And if I add those together, I get negative 7. So look at that. Now, you can actually write these in the box in whatever order you want. You could write x minus 6 and then x minus 1 because it doesn't matter what order you multiply in. So your choice. All right. In these next couple, notice that I have some opposite signs happening here, okay? And so one of these is a plus and one of them is a minus. And I'm multiplying this time to get negative 16. I want my add to be 6. So I could have negative 1 times 16. That would get me a negative 16, but Negative 1 plus 16 is not anywhere close to 6. And even if I switch where the negative is, so I have 1 times negative 16, again, these do not add up to any number close to 6, okay? How about negative 2 times 8? Oh my goodness. Okay, well, negative 2 times 8 is negative 16. And if I add those together, I do get 6. So yeah, but I had to put these in the right spot. I have x plus 8. The 8 has to be the positive number. X minus 2. The 2 has to be the negative number. All right, in this last one, I need to get multiplied to negative 4. So let's see, negative 1 times 4. And I need those to add to negative 3. Well, negative 1 times 4 adds to positive 3. So what if I had 1 times negative 4? Yeah, that would add to negative 3. Okay, so I should have x positive 1 and x minus 4. All right, so what patterns do we notice? Well, I'm noticing a couple of things. I'm noticing that my x squared is always split up for me. In fact, like in all these problems, it was already split for you, but I'm noticing that everything is written as these two groups where I would have x times x, which is x squared. And I'm also noticing that the numbers in the factors, these two groups that we have, add to the b term. Remember, the b term is with the x, and multiply to c, which is that constant. All right. So I'm going to give you a chance to work through this page here. On this page, you have a box for some matching. You also get to fill in some groups down here. I'm just going to talk about one of these with you and how we would check it on Desmos. And then I'm going to go ahead and fill out this quick notes box with you and then give you a chance to try some things on your own. All right, so I'm not going to do this problem 6 with you. I'm actually going to come down here and do problem 9 with you. Actually, I'll do problem 10 with you. Notice that in problem 7, one group is already filled out for you. In problems 8, the row of 8, one group is already filled out for you. Notice in row 9, only the X's have been filled out for you. You have to figure out the signs and the numbers. And in row 10, nothing is filled out for you. So I'm going to go ahead and work through row 10 with you, and then we'll check it on Desmos. So in every problem that's been set up for you, this x squared has already been split as an x times x. One x in each group, because if I were to multiply this out, I would get x squared with that x times x. We said that we need numbers that multiply to the constant, so negative 1 times 6 would give me negative 6. And I need these numbers to add to negative 5. So if I add these numbers together, I would get positive 5. So let's switch it then. 1 times negative 6. Yeah, that gives me negative 6. And if I add these together, I'm going to get negative 5. So that means that my 1 should be positive, so x plus 1, and my 6 should be negative, so x minus 6. Or you could write it as x minus 6 and then x plus 1. It does not matter what order you write those in. Now let's use Desmos to check. So in Desmos, I'm going to type the original expression that was given to me in the first bar, and I'm going to type the new answer that I came up with in the second bar. And I'm going to check to see if these are the same. Okay, so I have in my first bar, I'm going to have x squared minus 5x minus 6. And in the second bar, I'm going to have x, so in parentheses, x plus 1 times x plus 6. Or you could write x plus 6 times x plus 1. Or sorry, x minus 6. That's why it didn't like my answer. Minus 6. There we go. I'm going to hit enter. And when I click this blue button over here to turn the equation off and on, I notice that my red graph and my blue graph are the same. So I know that I have factored this correctly. It's a great way to check if you have found the correct answer. All right, so let's fill out this quick notes box, and then you'll have a chance to try some on your own. So when we factor, to factor means that we're going to break apart into two factors. So first little note here, to factor means to rewrite as multiplication. And so that's our goal. And so if we are given something in this form here, this trinomial form, in order to get this x squared term, we have to break x squared up into x times x, because x times x gives us x squared. So I'm going to break this apart into factors, two items that are being multiplied together. And in those factors, I'm going to split that x squared up into x and x, so that when I multiply this out, I get the x squared. The next thing that I'm looking for are factors of the constant. So factors of c. Remember, this is really ax squared plus bx plus c. So I'm looking for factors of that constant 10. So I'm going to make myself a little table here. I want numbers that multiply to 10. I'm going to write 10 up here. And I want to choose the set of factors that add to b. So I want these numbers to multiply to 10 and add to 10, or add to 7. There we go. Multiply to 10 and add to 7. Okay, so let's look at factors of 10. 1 times 10. Out of room, sorry. So 1 times 10, and that gives me 10. If I add those, though, I get 11, so that's not going to work for me. All right, 2 times 5 gives me 10, and if I add those, I get 7. Yeah, that works for me. So I can say plus 2 and plus 5. Or you could say x plus 5 times x plus 2. It does not matter what order you put those in. And this actually would be my final answer, either one of those. But you can always check by multiplying, okay, or on Desmos. So if I multiply this out using my box method or my break apart method, I'm going to get x times x, which is x squared. And I'm going to get x times 2, which is 2x, and 5 times x, which is 5x. That's how I get that 7x. And 5 times 2, which is 10. That's why I'm looking for factors of 10. And this works out. So again, this set of factors is my final answer. Or this set of factors. Doesn't matter which way you write it. All right, so your job is to make sure that you go back and work through this page here, this second page. And notice that on this third page, nothing is broken up for you at all. You get to break everything up, which means you get to start off by rewriting every set of groups, okay, and splitting that x squared up into x and x. And if you have any questions, please let me know.